Hello and welcome to 8.5, Integration of Rational Functions by Partial Fraction. So in this section we're going to be looking at the classic technique of partial fraction decomposition to integrate our rational functions. Okay. So now a lot of times we have to make sure our denominator in our problem is in a factored form. If it's not in a factored form, then we try to factor it. Okay. Luckily, in this first example, our denominator is in a factored form, so we can start by trying to decompose this fraction into partial fractions, and then we'll try to integrate from there. Okay. So we know that we could write this into three fractions. We have three denominators. Right, so we would have, for example, a over x minus 1 plus b over x plus 1 plus c over x plus 3. And so what I did was I spaced it out intentionally because I want to show you guys how to go about getting these partial fractions, right? The idea between each of these three fractions is we want to get a common denominator, right? Now the common denominator happens when we take all three of these factors and we put them together, right? So for example, if we have x minus 1, we're missing the other two denominators, the other two factors, so that means we're going to be multiplying by the other two factors here, x plus 1 times x plus 3. Okay, and then typically that's what we would do in order to be able to get one expression with the same denominator. Right, x plus 1 times x plus 3. And then for the middle one has x plus 1, so it's missing x minus 1 times x plus 3. So x minus 1 times x plus 3. And then the last one, x plus 3, it's missing x minus 1 times x plus 1. Okay, so that would be the initial setup for it. So the next step is we want to multiply these factors that we just put in here, x plus 1 times the x plus 3. We have a in front of them. Okay, so we still have a. And then inside here we have, just FOIL it, x squared plus 3x plus 1x, that's plus 4x plus 3. Plus b, and then FOIL these two, x squared plus 3x minus 1x, that's a plus 2x minus 3. And then plus c times, this is a difference of squares, so this becomes x squared minus 1. Okay. So now we could distribute the a into the trinomial next to it, b into its trinomial, and c into its binomial. Okay, so let's distribute. So we have ax squared plus, that'll be 4ax plus 3a plus bx squared plus 2bx minus 3b plus cx squared minus c. Okay, so next, looking at our initial problem, we're going to try to group together all the x squared terms. Right? Then we're going to try to group together all the terms with just the ax, with the x's. And then we'll try to group together all the terms that just have an a or a b and a c. Okay? So, let's take a look at all the terms that have the x squared on it. Okay, all the terms that have x squared on them would be, we have that, and we have that. Okay, so let's say we have a x squared plus bx squared plus cx squared. And now all the terms that have x's on them, just plain x's. So we have 4ax plus a 2bx. So 4ax plus 2bx. And then all the terms that have just the a, b, or a c. So we have a 3a minus 3b minus c. So we have 3a minus 3b minus c. Okay, now let's just rewrite this in another way, the ax squared, bx squared, cx squared. This will just be, if we factor out the x squared, we would have a plus b plus c x squared, right? And then for the ones with the x's, if we factor out the x to the right side, that would mean that we have 4a plus 2b x. And then for the last one, that would just be the way it is, 3a minus 3b minus c. Okay, so now looking at our initial problem, x squared plus 4x plus 1. Focus on that numerator. X squared, there's a 1 in front. The x has a 4 in front, and the constant is just a 1. X squared plus 4x plus 1. X squared plus 4x plus 1. So that means for our x squared, it's just a 1x squared. Right, that means a plus b plus c, those are the ones with the x squared. That means a plus b plus c has to equal 1. It has to match up to that value there. And then for our the ones with the x's, the 4a plus the 2b, that has to be equal to the 4. And then the 3a minus 3b minus c, that has to equal to 1. Okay, so it's kind of like a little system we have going on here, like a system of equations. Okay, so let's write those equations down. So we know that a plus b plus c equals 1. 4a plus 2b equals 4. And then 3a minus 3b minus c equals 1. Okay, so this will help us solve the problem. We have to obviously figure out what's a, b, and c before we go any further. So what can we do? Okay, well, we could take the top equation and the bottom equation. If we add them together, we would get rid of the c. Right? If we do like an elimination method, we would get rid of c. And then we could have an equation in terms of a's and b's, and then we could work with the middle equation to solve for a and b. Okay, so I'll start that off on the side here. A plus b plus c equals 1. 3a minus 3b minus c equals 1. Let's add these together. That means we have 4a, 1b minus 3b, that would be a minus 2b, plus c and minus c, that eliminates, equals 2. Oh, perfect. So we have this equation that we just got, and we could add it to the middle equation over here. Okay, so let's do that. So we have 4a minus 2b equals 2. And let's put the middle equation down here. 4a plus 2b equals 4. We add, we get 8a minus 2b and plus 2b. They cancel, they eliminate. And then 2 plus 4 equals 6. We divide both sides by 8. So we get a equal to, reduce that, 3/4. Okay, so if a is equal to 3/4, we could plug that 3/4 into either a, and we could solve for b. Okay. Well, let's plug it into this middle equation, the one we just used here. So we have 4 times 3/4 plus 2b equals 4. Okay, so doing this, the 4's cancel. We're left with 3 plus 2b equals 4. Subtract the 3 from both sides, so we have 2b equals 1. And then divide by 2. So b equals 1/2. Okay, so far so good. So we have a is 3/4, b is 1/2, and now let's go back and figure out c. Okay, so we could go back into the top equation. A plus b plus c equals 1. Right, so we have a plus b plus c equals 1. So a is 3/4, b is 1/2, c equals 1. Okay, 2/4 is b, 2/4 and 3/4 is 5/4. So we have 5/4 plus c equals 1. Subtract 5/4 from both sides. So that means we have here 4/4 minus 5/4, which is negative 1/4. Okay. Good. So now we have a variable and we have all three variables solved for. Right? A is 3/4, B is 1/2, and C is -1/4. Okay, so that means we could go back to our problem that we initially set up, and we're going to plug in for the A, the B, and the C. Okay, for that original, before we did all the work. Okay, so we have, let's do the integral. A was 3/4, so we have the 3/4. We could write it like this, make it a little better. 3/4 times 1 over x minus 1 plus 1/2 times 1 over x plus 1. And then C was a negative, so we're going to do minus 1/4 times 1 over x plus 3. And we're going to integrate this with respect to x. And then so when we integrate these are pretty straightforward. These are all turned into ln. Right? So we would say here, for example, 3/4 times natural log of x minus 1 plus 1/2 ln absolute value of x plus 1 and minus 1/4 ln absolute value of x plus 3 plus c. Okay, now if you want to use a different variable, because the c here is the same c that we used up here when we did the partial fractions with the ABC, we recommend a different letter, so you could use k, for example, for a constant. Okay, it's just a little side thing. And I would recommend it because you don't want it to be confused with the C. Like, wait a minute, am I still using that C here, or am I using just my traditional constant? So use the K. K is okay. Alright. Any questions on that, just bring it up in email or during the lecture. Use partial fractions to evaluate this one. Okay, so we have 6x plus 7 over, and then the bottom is basically factored form. It's x plus 2, the quantity squared. Now, anytime you have the denominator raised to a power, what you want to do is you want to set up one fraction. You want to set up one fraction as if it's not raised to any power. So as if it's just a plain x plus 2. But then you have to also add in another fraction when you have it raised to the next power up. So x plus 2 squared. Okay, so that's the typical rule when we have the denominator raised to powers. Right? We always want to account for different versions of the denominator. You could have x plus 2 as the fraction. You could also have x plus 2 squared as the fraction. Okay. So now the common denominator between the two fractions would be x plus 2 quantity squared. Okay, so what we would do then is for this one on the left, we would do, let's multiply by another x plus 2 here. Okay, and then if we distribute that a, we would get ax plus 2a, and this one we just have the plus b, and that would be equal to, let's just set it up, equal to the numerator, 6x plus 7. Okay, so now there's only one thing with an x in it, so we're going to try to match those up. So we know that ax, that would be equal to the 6x. And now for just the constants, we have a 2a plus b, that would be equal to the 7. Okay, so now we know right off the bat then, if ax, and that's the only one with the x in it, that means a has to be 6. So now if a is 6, let's plug that into the bottom one here. 2 times 6 plus b equals 7. So that's 12 plus b equals 7. So that means b equals -5. Okay, so that means we're ready then. So we would integrate. We had a over x plus 2, so that would be 6 over x plus 2. And then here, because b is negative, we would put minus 5 over x plus 2 squared. Okay, so we could integrate that rather easily. So for the first one, this would be 6 times the ln of x plus 2. Now here for this one, picture this as this. We have 5x plus 2 to the -2. So that means when we integrate it, that would make that go, that -2 would become -1. And then we would divide by -1. So that means this would be a plus 5x plus 2 to the -1 plus c. And you could leave it like that, or if you want to write it in the fractional form, that's fine as well. Okay, well that would be the final answer. Okay, let's take a look at another problem. Use partial fraction to evaluate. Okay, now notice this one, you're looking at something that is top heavy, so the degree of the numerator is larger than the degree of the denominator. In this case, partial fractions would have to happen after a few steps in the beginning. So what we need to do is first do a long division. Right? Do a long division, polynomial division, to figure out what would be the fractional piece that we have to account for. Okay, so let's do that first. So we have top goes inside, 2x cubed minus 4x squared minus x minus 3 divided by x squared minus 2x minus 3. Okay, so we divide the leading terms. 2x cubed divided by x squared, that's an x. Okay, so we have 2x, right? Let's do that on the side here. 2x cubed divided by x squared, that would be a 2x. Okay, so 2x. So to multiply that 2x into this divisor, so you're distributing basically. 2x times x squared, 2x cubed. 2x times -2x would be -4x squared. 2x times -3 would be -6x. And now subtract. 2x cubed minus 2x cubed. that's gone. Negative 4x squared minus negative 4x squared, that's gone. Negative 1x minus negative 6x. Negative 1 plus 6 would be a plus 5. I always write the minus here to remind myself that I'm subtracting. So negative 1 minus negative 6, there's a double negative. It's like negative 1 plus 6. So you have plus 5x, and then you want to bring down the minus 3. Okay. And now can you divide 5x by x squared? You cannot, right? So we stop there. This will be a 0, and then this will be the remainder, but we put it as a fraction, right? So we would have 2x plus 5x minus 3 over our denominator, x squared minus 2x minus 2x minus 3. Okay, so this is what we're going to integrate then. Okay, so it becomes this, 2x plus 5x minus 3 over x squared minus 2x minus 3. Okay, so we could do that. In a sense, we're basically splitting this apart into two problems. You have the first part, and you have the second part. Minus 2x minus 3. Okay, so we're going to do the partial fractions, one for the right side. If we integrate the 2x, we get x squared. So that one's done. So let's focus on the right side here with the partial fraction. Okay, now can we factor the denominator? So we have the 5x minus 3. So this would factor, right? X squared is x and x. Multiplies to negative 3, adds up to negative 2. That would be a negative 3 and a plus 1. Right? Negative 3 plus 1 is negative 2. Negative 3 times 1 would be negative 3. Okay, good. So this is what we have to factor then. So we would say a over x minus 3 plus b over x plus 1. Okay, so now we know that in order to do the partial fractions, a would have to get multiplied by x plus 1. And then b would have to get multiplied by x minus 3. Okay, so we have, we're going to distribute the a here, so ax plus a plus bx minus 3b, that's going to equal the 5x minus 3. Okay, so sort out the ones with the x's. So we have ax plus bx. So we know that ax plus bx has to equal 5x. So we know that a plus b has to equal 5. Okay, and then for the constant, we have a minus 3b. A minus 3b, that would have to equal negative 3. So a minus 3b equals negative 3. Okay, so now we could solve this. So we could do the top equation, a plus b equals 5. We could subtract away the bottom equation, or if you don't feel comfortable subtracting, you can multiply the bottom one by a -1. Right, so if we do that, that would make it -a plus 3b equals +3. And now we could add. Okay, a plus -a, that's gone. So we have 1b plus 3b is 4b. 5 plus 3 is 8. Divide by 4. So b equals 2. And if b equals 2, let's put that into the top equation. A plus 2 equals 5. So that means a equals 3. Okay, so that means we could go back. A is 3, b is 2, and we could plug those in. A is 3, so we're going to integrate 3 over x minus 3 plus 2 over x plus 1 . Okay, so easy integration. Let's keep in mind we had the x squared from the beginning, so bring that down. So we have the x squared plus, you could say here 3, right? Pull the 3 on the side, 3 ln of x minus 3 plus 2 ln of x plus 1. And we didn't have a c being used in this problem, so plus c. And that would be the final answer. Okay, let's take a look at our next one. Use partial fraction to evaluate. Okay, so we have in the denominator basically have x squared plus 1, and then we have x minus 1, the quantity squared. So we're going to put x minus 1, the plain version, and then x minus 1, the squared version. Now, one thing you have to note, whenever you guys do this with your denominators, the numerator has to be 1 degree less than your denominator. So here, this denominator of x squared plus 1, this is a quadratic, right? Degree 2. So the numerator here is going to be a degree 1. Okay, so we're going to see that instead of just a plain a or a plain b, this one we're going to say is ax plus b. Okay, so if this is a quadratic denominator, the numerator is going to be a linear degree 1 numerator. Okay, here this is x minus 1, so we could just put regular c. And then this is x minus 1 squared, and this will just be a plain d. Okay. Now, another question may arise, like, okay, so you say that here this is a quadratic, we got the linear term. Well, if we expand this, this will be a quadratic, so shouldn't this be like a linear numerator? You have a point, yes, it could be a linear, but this denominator is basically a cousin of this one. Okay, you have to think about it like that. The x minus 1 quantity squared is a factorable denominator. And it's basically another version of this guy in the middle. Okay, so if this one gets the constant numerator, so will this one. Okay, that's how you have to remember it. Okay, if it's an irreducible quadratic, then you could go with the linear, like this one. Okay. All right, so let's go ahead and figure out our common denominator will just be x minus 1 squared times x squared plus 1, right? So that means for the one on the left, we have to multiply this by x minus 1 squared. And then for the middle one, we have to multiply this by x minus 1 times x squared plus 1. And then the one on the right, we have to just multiply this by x squared plus 1. Okay. So let's continue. We have ax plus b. This will have to multiply with, we're going to expand on the x minus 1 squared. So that's going to be x squared minus 2x plus 1. And then plus c. Let's expand on that, FOIL it out. That's x cubed plus x. Okay, so we have x cubed plus x minus x squared. So minus x squared plus x minus 1. And then d. Well, d, we could just distribute that out. So it's d x squared plus d. Okay, for the ax plus b, we're going to have to actually multiply that out. Okay, so that'll be ax times x squared is ax cubed. Ax times negative 2x would be negative 2ax squared. Ax times 1 is ax. Okay, next do the b, plus bx squared minus 2bx plus b. Okay, distribute the c into its parentheses. So we have plus cx cubed minus cx squared plus cx minus c, and then we have the dx squared plus d. Okay, so we'll group together the x cubes. Right, now looking back at our problem, do we have any x cubes in our numerator? We don't, so the x cube has to equal 0. So we know that we have ax cubed plus cx cubed, that has to equal 0. There's no x squareds in our original problem, so that has to equal 0. So let's see what we have here. Those are gone. So we have x squared, so negative 2, let me circle or underline, negative 2ax squared plus bx squared minus cx squared plus dx squared. Wow. that has to equal 0. Okay, so negative 2a. Alright, let's just do it with the a's, b's, and c's, and d's. So negative 2a plus b minus c plus d. These are all for the x squareds. This has to be 0. Here we got the a plus c has to equal 0. Okay, plane x's. We have ax minus 2bx, ax minus 2b plus c, and then those x's, they have to equal negative 2, because in our problem, right, we have a negative 2 here. And then constants, we have some constants, right? We have a b minus c and a plus d. B minus c and a plus d. That has to equal 4. Okay, so good. Alright, so we know, let's summarize this over here. We know that a plus c has to equal 0. We know that negative 2a plus b minus c plus d, I should have put a d there, for x squared, plus d, that equals 0. A minus 2b plus c equals negative 2, and then b minus c plus d equals 4. Okay, so right here, this last one, notice you have b minus c plus d. Well, you have the same sequence up here, b minus c plus d. Well, you can just swap that with 4. Right? Put the 4 in there. Okay, so we have negative 2a plus 4 equals 0. And then we could bring the 2a over, so we have 4 equals 2a divided by 2, so a equals 2. Okay, put that 2 in here, so we have 2 plus c equals 0. That means c has to be negative 2. Okay, so that's good. And now we could solve for the other ones then. Okay, let's go into this third equation. A is 2, so 2 minus 2b plus c. c is negative 2 equals negative 2. So 2 plus negative 2, that's gone. So we have negative 2b equals negative 2 divided by negative 2. So b equals positive 1. And now let's solve for d. So here's the bottom equation. So we have b is 1 minus c, which is negative 2, plus d equals 4. The minus and negative is plus, so 1 plus 2 plus c equals 4. 3 plus c equals 4. Subtract 3. So c also equals 1. Okay, so a equals 2, b equals 1, c equals -2, and I wrote here c, but I was thinking d. D equals 1. Okay, so we're ready to finish it off then. Okay, so let's set it up. We had the integral of ax plus b, so that's going to be 2x plus 1 over x squared plus 1 c was -2, so we'll have minus 2 over x minus 1 plus d was 1 over x minus 1 quantity squared. Okay. Now what we could do here for this part, because this doesn't look like the ln of this fraction we could split apart into two fractions. Right? We could say the first one is 2x over x squared plus 1 plus 1 over x squared plus 1, like that. Minus 2 over x minus 1 plus 1 over x minus 1 squared. And now we could integrate this. Okay, so now 2x is the derivative of x squared plus 1, so if we do ln of that, that's fine. So we say ln of x squared plus 1 plus, now integral of 1 over x squared plus 1, well, that would be the inverse tangent of x. Okay, and then here this will be minus 2 times natural log of x minus 1. And then here this will just be, I could integrate this regularly, this will just be minus 1 over x minus 1. And then we could put a, we use c in this problem, right? We could put a plus k. And that would be the final answer for that one. Okay, so let me pause this and I'll continue with part 2. Yeah, I'll stop it here for this will be part 1 and we'll continue in part 2. Okay.